So hello everyone and welcome to the Blockdaemon Podcast. Today I'm joined by Nye Liu from Blockdaemon to discuss all things nodes, blockchains, NodeOps, and all things Web3. So Nye, welcome to the Blockdaemon Podcast. Great to have you.
Hey Connor, thanks for having me. Happy to be here.
So Nye, just talk me through how you came to be working in Web3, blockchain, that kind of background.
Yeah, absolutely. I like a lot of people in blockchain. I think since it's a new industry, a lot of people that kind of entered the blockchain industry probably didn't come in with a lot of technology experience. Not necessarily because they were necessarily inexperienced per se, but just because the technology is so new that there wasn't actually a lot to research or understand other than the bare minimum of the basics of trading. So that was kind of interesting for me when I've had a friend of mine way back when I had kind of taken a break from working for a bit because I got laid off, went through the whole .com cycle. I was kind of done for a bit, and he kept coming to me. He said, "Hey, Nye, blockchain," and I'm like, "Yeah, not really," because I was coming from a telco background, so I came from networking, doing switches and routers, and kind of basically from really the bare bones hardware. So I wasn't even initially a software guy. I was building networking gear. So as it kind of developed my career, more and more kind of programming, and then kind of a little bit of OS development because I had to do kind of like embedded systems, and all my experience in technology was based on really from the ground up, from the bare minimum of like how CPUs really work, all the way through memory, and then networking, the birth of networking. So I was kind of done. I'd been there for a long time, and I was like, no, man, I can't. I'm not in the mood. Kind of like bounced around for a bit, still didn't do anything. I can see him again. He'd be like, "Hey, Nye, blockchain." I'm like, "Oh man, no, I can't." Anyways, he bugged me a couple more times, and I finally, my wife was like, "I know you say you wanted to take a break, but I think really, try something different." Because the other reason I was like, "Oh, it's not really my comfort zone, not really my thing." She's like, "No, I know you. I know you'll get in it, and then you'll be 100%." Like, "All right, fine." He's like, "Nah, blockchain." I'm like, all right. He's like, no, trust me. Just come in for a couple months. We'll hire you as a contractor. We'll pay you a good amount of money. If you don't like it, no big deal. If you like it, stay. So I said, okay, sure. So I spent the first couple months at Blockdaemon. I met a couple just really amazing folks, actually based here in Galway. So this is back in the OG days with Jonas and Andrew and Rick and some of the other. And I was like, as soon as I met those guys, I was like, oh man, I'm digging this, because I was now surrounded by like super smart people, and I was so used to just being really jaded and all this other stuff. And I got super excited, and literally like maybe 3 months later, I was like, yeah, I'm in full time. So so that was really around the 2018 timeframe. So right around when things were getting started, and we were all super new. We were all just kind of learning all these things. We were doing stuff that nobody else was really doing at the time. Everybody was kind of running their nodes, but nobody really thought about it in really kind of a, not so much a kind of a large scale kind of way, but in a really kind of professional, how would you approach it as a service sort of way, rather than just kind of a hobbyist? How would you approach that? And because none of the tools were built that way. So that's how we got started. And today, I guess this is all through Constantine, who's like kind of his baby. And so here we are today, and we're like one of the largest operators of nodes on the planet. I think it's pretty clear that we made some right decisions somehow, but we're here. So yeah, that's how it happened.
You mentioned that Blockdaemon is one of the largest node operators in the world, but taking a step back, what is a node, and what is a node's role within the blockchain ecosystem? And then what goes into managing a node on a day-to-day basis?
Absolutely. So basically a node is a participant in any given blockchain network, and every blockchain network is made up of a bunch of computers that do various things. Back in the early days of one of the original blockchains is obviously everybody knows Bitcoin. And so one of the first instances of a node was a miner, somebody who was like doing heavy computing to contribute to consensus and hopefully make a little bit of money on the side. And that kind of it shifted throughout the years, because at some point you actually needed some sort of way of actually interacting with the blockchain. So I wanted to be able to submit transactions. In other words, I want to move some funds from one account to another account. And how do I do that from my home computer? How do I do that from a phone? Like, how do I do that from a POS system? How do I do it from an ATM or whatever? So you need some access. You need an on-ramp on that system. And those on-ramp computers became kind of independent of the miners, and they just became access points. So you can look at them kind of like on-ramps onto a freeway in a way, or if you're familiar with the internet, it's kind of like your ISP a little bit. And they give you basically direct access directly into the networks. And that kind of graduated into something else, as it became as we wanted moved away from proof of work and proof of stake, some of the other node participants were something like a validator, a staking node, and those nodes would also be participating in the network, but in other ways. Instead of mining, they would participate by just being purely consensus through various algorithms. So, and you can see that today, nodes are roughly split into those two categories. They're primarily access, so calling an RPC or submitting a transaction or participating in consensus directly. Proof of work, not so much anymore, but proof of stake, so that would be a validator.
Sure. And I suppose, what are some of the advantages of outsourcing nodes management to a professional blockchain operator like Blockdaemon versus, as you said in the early days, a company managing in-house, doing their own node operations?
Absolutely. I think the main thing to look at is that the operation of these kinds of nodes is very different from what a normal company would do if they had to, spin up a bunch of infrastructure. They would typically, back in the day, they would do it in-house. They'd have a rack someplace, or they'd have a colo. And then later they started moving things into the cloud. But the model was always kind of the same. It was like even, Web 1, Web 2, they were all client server. They were all asymmetrical, right? You had somebody who wanted to talk to a service, and they would submit a request to a web page, and you get a response back. Now, you could say, hey, well, that's kind of what you're talking about, what a node is. Well, not really, because a node isn't just serving those requests. It actually has to participate in a very large peer-to-peer network. So it's not so much, I've got a server someplace now. It's like I actually have a participant, a peer, in a very large, complicated network that has to talk globally to a bunch of other nodes. So that model is a little different. It's kind of back to the old throwback of the kind of the old school. This is what the internet was back in the day. It was all peer-to-peer. It wasn't this whole, throw everything in the cloud in a centralized location. The whole idea of blockchain in general was to decentralize. So that comes with its own challenges. You can run nodes in the cloud, but you still have to manage them in the sense you still have to keep them updated. You have to make sure that they're running properly, and all those kinds of things. Updating it's really, really tricky because some of these nodes, the software is relatively new, so it takes a lot of upkeep to make sure that they're running. Sometimes when you're starting up a new protocol, something that's brand new to the whole world, it's very, very unstable and requires a lot of babysitting to keep running correctly. Finally, if you have your own monitoring system for your own standard kinds of cloud computing or either your own in-house computing, those monitoring systems aren't really designed to monitor what is actually happening as far as, how a node is participating on the network and whether it's working well, where it's not doing well. So all those kinds of things is something you'd want to go to a professional like us for, because we can do that. And the other difference for us is that, for most people, it's enough for them to run one or two protocols and they're happy. But for us, we have a lot of experience across a wide variety, like dozens of different protocols. And that gives us the breadth of expertise and understanding to really okay, what are the finer points of each one of the different protocols? So it gives us the ability to really shift really quickly and adopt new protocols as well. And it's something also you'd want to come to us for instead of okay, well, I want to, instead of running a Bitcoin node, a Lightning node, now I want to run something else, a Solana node. Now you've got a whole new learning curve to learn exactly how to run those things. Whereas us, we've seen so many different ones, it's relatively easy for us to pick a new protocol and say, hey, no, we've got the service for you. It's ready to go.
You mentioned there that, we monitor the node to make sure that the customer doesn't have to. We look after that on their behalf. But in terms of the data that Blockdaemon would look at to ensure good node health, to make sure that, everything's ticking over correctly, talk to me about the monitoring that goes into, how we manage nodes and what are the metrics that you look at to ensure that network is running smoothly, customers' nodes are running smoothly, that kind of thing.
Yeah. So the bottom line is so first of all, there's kind of the first layer of monitoring, which everybody understands. It's the, my CPU load and my memory usage, my disk usage, my network bandwidth usage. So all those things you'd see in a typical, just kind of regular, cloud computing or any kind of a monitoring. So that's the first kind of conventional monitoring that everybody should be familiar with. The second kind is blockchain-specific monitoring. And that can be divided also into kind of two different parts. One half is things that are common to every single protocol on the planet and things that are kind of special for a particular protocol. So I'll give you an example of something you might monitor that's common to all protocols. And that would be something as obvious as the number of peers that I'm connected to, right? How many other computers am I talking to? If I'm only talking to one or two, probably things aren't going so well. If I'm talking to hundreds, I'm in pretty good shape. That means I'm well connected to the rest of the network. And the next most obvious one is block height. Am I caught up? Am I synchronized with the rest of the network? And that varies too per protocol, depending on how fast they generate new blocks and, whether or not they're, sometimes they can be very speculative. So depending on which node you're on, those block heights kind of move. So even in those common sense, like, okay, well, peers and block height are common, still per protocol that varies, which brings us to the next topic where every protocol is different. So every protocol has other things you might want to monitor that has nothing to do with any other, like it's unique to that protocol. So in the case of So, for example, Ethereum, another obviously one of the most the largest networks in the world, is something like mempool size, mempool usage. Those sorts of things that, okay, yeah, it's a common thing. Maybe some other protocols have it, but by and large, it's not completely general. It's maybe specific to Ethereum. So that's something else we might monitor to see exactly how much mempool we're using. We've got too much stuff queued up. Is it not really doing anything? Like, what's going on there? Maybe it looks like it's connected, but it's not really doing anything. So those sorts of things.
You mentioned that, we look at cloud data, but that brings us to the topic of where these nodes live, so where they sit. When it comes to the hardware that the nodes live on, how important is the choice of hardware, and what's the different types of hardware that Blockdaemon and other providers could use to host nodes that provide the highest kind of reliability, uptime, and infrastructure for customers?
Absolutely. So this, again, this varies. So there's some lowest common denominators for all protocols, like most things. So there's this kind of a notion that, I can probably run most things in your average 4 CPU or 8 CPU thread, CPU or threads VM in, say, AWS or Google or Azure. But sometimes, it depends. Some protocols are a lot more, they require a lot beefier hardware, or they require a lot more network bandwidth, or they require a certain kind of connectivity, or, you have a customer that wants things in a certain region. Maybe regulatory for legal reasons, you have to be a certain region, and maybe they're not available in the cloud of your choice. So the short answer is, it really depends. It depends on a lot of different things. And again, this is something that Blockdaemon, we have great expertise in. If you had a conventional node operator they're used to one protocol and they say, well, we run everything in AWS. It's like, all right, good luck with some of the other protocols. You're going to have some trouble. So that's another reason why Blockdaemon, we can tailor those. And then most importantly, it's very easy to say, well, just throw a lot of hardware on it. Maybe it'll work. Well, that's not so great either. If you're running 1,000 nodes, that can add up pretty quickly, and we'd have to pass that cost on customers. So it's very important for us to make sure that whatever we're running is specifically tailored to whatever the purpose of that node is. And it might not even be specific to that protocol, but maybe what that node is actually doing on that protocol. And it can affect what kind of hardware is really optimized for it.
One of those protocols with the high hardware requirements is Solana.
Absolutely.
That requires a serious bit of kit to run.
Absolutely. And it requires a serious bit of kit for a lot of different reasons. Primarily, obviously, to keep up with the proof of history algorithm, it basically has to be running 100% on one of the cores to keep up with the kind of continuous hashing that it has to do. So, that alone can take a significant amount of the CPU power, and it doesn't leave much necessarily for anything else if you don't have a sufficiently powerful machine. Solana itself is also a very, very chatty and very, very fast network. So obviously, it has to do a lot of processing and has to do a lot of it's got to do voting and, transaction processing and all these smart contract processing, and all that stuff takes significant amounts of CPU. It's also, because it's so fast, it also takes a bunch of disk space, and it'll eat disks very quickly. So it'll eat disks in the sense of it'll chew up space really quickly because the chain itself grows so quickly. And because there's so much throughput, there's so many transactions per second, I/O goes through the roof too. So you need a lot of I/O. You need SSDs. It'll probably eat your SSDs too. Sooner or later, SSDs wear. So as SSDs wear, then you need to start monitoring and making sure, okay, well, this one's about to go down. I need to start putting new drives in this. And then the dirty little secret of hosting in the cloud is network bandwidth. So you could say, well, I've got, Google, Amazon, they got pretty big fat pipes. It's like, yeah, they do, but they're not free. They don't want your data really going outside of their network. So they'll charge you if you send any kind of data out, called the egress costs. If you go to a conventional cloud provider, unless you have a lot of clout and they really like you, they're going to charge you a ton of money. And even if they do really like you, they'll still charge you a ton of money because they know. So that's one of the other reasons, at least for Solana, they may not have the hardware that you necessarily need. There's only maybe 5 or 6 CPUs that really work really great with Solana. There's other things you can do with other ones, but they're not ones you can actually easily get on either Amazon or Google. And so you end up you need specialized hardware for that. Then I said the egress costs will absolutely murder you on any of these conventional clouds. So another reason to maybe look for a different network provider. And also, because it's so network intensive, if you don't go to a Google or an Azure or Amazon, whoever you do go to has to have those network pipes, and they have to make sure that they're reliable. So if a cable gets cut, is your validator going to go down or not? Is it going to stay connected or not? So these kinds of things really, these are something that Blockdaemon, we've spent significant amounts of invested time and money and really thought into where we're going to deploy things for exactly all those reasons. So, it's very difficult for an individual. The barriers to entry are fairly high I think for Solana in particular.
For Solana in particular, I remember in 2021 and 2022, there were two instances where the network actually paused or halted for a few hours. And I know that we're not just an infrastructure operator. A lot of our engineers, are active in these communities. Tell me about perhaps the story of those two events, how yourself and other engineers liaise with the community to help restore the network in a troubling period for Solana.
Absolutely. I think the first thing I want to just kind of I want to lay the thing to understand about the Solana community in general, that these the operators that are involved in this community they're very dedicated to making sure that the average user's experience is a good one. So they're very invested. So, and you can see this when you're in there and if they're having some sort of outage, everybody bands together at once. They have what's the best way to get things running quickly? And it's not so easy. It takes a lot of work, and it takes a lot of folks that are super experienced and have seen all these things kind of before. And so for the case of Solana, I could get into the technical details, but one of the things you have to do is when a network forks or it splits, or in the network's case, Solana's case, kind of people get out of sync and they're no longer a consensus. One of the first things you have to do is decide, where I'm going to restart, at what point in the chain I'm going to restart the network. And the only way you can do that is really kind of look around and ask everybody, okay, what's the latest block you guys got? Like, what's your latest finalized block? What does it look like? And it's great for somebody like Blockdaemon, we run so many nodes, we have a pretty good representative sampling. Like, we know, we've got, out of this many nodes, most of them have this one. So we vote, we like this one. And we'll get consensus from this community, say, yeah, we like that block too. That looks like the one that's the most recent one that everybody got that everybody can agree on. And then when you restart the network, you need to restart it based on what's called a snapshot. So a snapshot is basically exactly what it sounds like. It's a basically instantaneous snapshot of what the state of the network was at that particular point in time. So once you decide on a block, you have to create a snapshot. Now, these snapshot files are generally pretty damn big. Like, maybe at the time from the earlier restarts, they were like 4 to 5 gigs, but now, 10, 20, 30, 40 gigs, they get pretty damn big. So now you got to find a way for those that don't have maybe they don't have that most recent block, they need to all start from the same snapshot. So you got to find some way of, distributing these snapshots the rest of for the community to restart on. Now there is some built-in stuff in Solana that allows you to distribute those, but really it's not ideal when you're trying to distribute this very large file. You don't necessarily want to use the built-in Solana way of fetching snapshots. You kind of want to have a more distributed way. And that's the other thing Blockdaemon can contribute, because we have pretty good presence around the world. We can give pretty fast mirrors that can supply all this data. And since they're not in, AWS or a Google, we don't worry about egress costs. So we can serve, 50 gigabyte file to 100 people. It's not that big of a deal. So that's another way that, companies like Blockdaemon contribute. But I do want to emphasize, again, it's a cooperative effort. And it's not one of those things where, I don't make it sound like, they couldn't do it without us. Well, it'd be great if I could say that. But in reality, we all know that's not great for a blockchain, right? They can't be dependent on us. So I just want to emphasize that it is definitely a cooperative effort. But Blockdaemon does play a significant role in it.
You mentioned that having points of presence around the world can be advantageous for an infrastructure provider, but also for anyone running nodes that wants maybe a quick connection, low latency. Tell me about some of the advantages of having a local connection to a blockchain and Blockdaemon's points of presence in the world, and how that's an advantage from a latency perspective, from a connectivity perspective, to kind of serve local customers who need node access.
Absolutely. So, it's kind of it maybe might even seem like a bit of an obvious question. Like, it's kind of like anything else. The closer you are to your point of presence, the more likely your bandwidth is really good. But most importantly, like you said, latency is really important. Like, the speed of light being what it is, it's about as fast as we can go. So, I'm from the States, so I can say, it takes a couple 100 milliseconds or 100 milliseconds or so, 200 milliseconds to get from coast to coast. And that can be significant. And you really want to keep that, especially for something Solana, you want to keep that very, very low for your existing customers. You also want good network connectivity. So that's the other tricky thing. You want good connectivity with the rest of the network as well. So no matter what you do, you've got to be close to your customer, and you've got to have good connectivity with everybody else, all the other parts of the network. And then, as I spoke about before, you have other reasons, maybe legal or regulatory reasons. You have to be certain regions. So all those things really kind of contribute to the mix and make things really kind of complicated, especially if you have a customer who's maybe in a relatively remote region and they want access. Even though we might have a point of presence that's close to them, we may not be close to the rest of the network. So that's one of the other challenges that Blockdaemon has to really keep in mind when we're deploying nodes, because sometimes it makes more sense. Hey, look, I know you'd rather have a node close to you, but the rest of the network, you kind of need to kind of split split the difference. Can we put you here? It's a little closer to where you are, but it's also closer to where the rest of the network is.
When it comes to, you mentioned Solana, but, other proof of stake networks, as the industry moves towards staking as standard for blockchain networks, talk to me about the role that node monitoring plays in ensuring kind of a healthy proof of stake ecosystem, avoiding slashing events, but also how node monitoring plays a role in mitigating potential negative outcomes for proof of stake networks.
Absolutely. So, just kind of want to divide it into kind of two different realms. One is the service access RPC realm, where you just really want to provide a customer really good, reliable access. So they know that if, they want to submit a transaction, they see a market make a move, they want to be in there before anybody else. And if their node is down, they can't make the trade that they really, really want to. So that's an obvious, not even the validation side of things, just on the access side of things. You got to make sure that your customer stays happy. They may also be doing a lot of digging around on the network. They want to make sure that, they look at all the account balances. They're looking transactional history. So you need a lot of really high performance. And again, it has to be reliable because these guys, they depend on their node being run up 24/7. So it's super important for us to monitor kind of the performance of those RPC nodes, the access nodes, to make sure that they're responding quickly, that they're most of the, you want to get as many of those to make sure that the latency is low on any given request. You want to make sure as many of them gets through as possible. Preferably, you don't want to lose any. You want to make sure that there aren't holes in the history. If they want to access a certain block, you got to make sure that's there. And then obviously, the really difficult one is sometimes for validators. And that's that's where you can really run into trouble if you aren't really paying very close attention to how all your things are running. Want to make sure validators doing exactly what it's supposed to be doing. And if it's not, connectivity is not good, or you've got your keys are kind of set up wrong, or God forbid there's a security incident, you got to find some way to make sure that you've got monitoring in place that lets you all those things know ahead of time if something's going wrong. If I'm starting to drop peers or the network, I can see there's some peers coming in and out, connectivity errors. If my disks are getting full, I said before in Solana's case, my SSDs are starting to wear. All these things, you have pretty good indication of what's happening. And if your monitoring is good, you can catch it before an event. And that's really the key, what happens. So, one of the obvious examples, I know there's the infamous OVH fire that we had a significant amount of nodes in the OVH data center, but we could see things started to deteriorate pretty quickly. And, we scrambled to try to make sure we still had connectivity for a lot of other backup nodes in different places. So that was a bit of a scramble, but we did have a good heads up that something was going on. And next thing you know, there's a picture of their data center burning down. And thankfully, none of our nodes were actually in the ones that were burning down, but they were all affected because the entire data center did go down. So that's a good example of where monitoring might catch some things sooner. You can see things start to fall apart and you're like, oh, that doesn't look good. We've got to do something now. So yeah, it's an interesting topic. And the other thing I wanted to point out is, again, we have this mix of monitoring of things that are common to all protocols and things that are different. And it's really important in monitoring your system that you do as much as you can to make as many protocols as possible look mostly the same. So you're not replicating, you're not having to tailor every time you got a new protocol. I got to rethink how that's going to look in your monitoring system. So you want to have a really uniform look. You want to look everything needs to kind of look the same in your monitoring system. So you're not having all that replication of effort and all this weird special sauce in every part of your non-monitoring stack. So it's super important. And part of our design is to get that uniformity together. So identify the things that are the common to all protocols and try to make that go through the trouble of kind of massaging that data early in the kind of the monitoring stack so that all the data looks the same in your monitoring stack. And it's super important. And it's something that only literally Blockdaemon really can do because we're the ones who are exposed to so many different protocols. If I only run one, I wouldn't know what that looks like. But if I run 50, I kind of know, okay, well, out of these 50, these 40, they kind of do this, this, and this. So all this kinds of data will make it all look the same in our monitoring stack. And in general, in our data stack in general, it makes sense to kind of unify those early as possible, so you're not polluted with all kinds of different protocol-specific things in your monitoring stack or your data. That's the other thing that's really hard to, I think, one of the hardest things to really get right. And I think the temptation is always to, well, let's not worry about it. Let's do what we can, and we'll get back to that later. But, that almost always comes back to bite us in the butt. It's like, no, you want to really get all that stuff right the first time. You want your data, garbage in, garbage out. Your data's got to be good from the word go. And it's challenging when you're talking to different protocol developers because they also live in their little bubbles. They only know their protocol and they only think they need to do one thing. And they're not really cognizant of the kinds of things sometimes that Blockdaemon needs to integrate with our environment. So we can launch your protocol needs to launch just like the rest of them as much as possible. So that's the other thing that can be important with the communities is to really say, hey, look, we're not going to say we don't really like the way you run things, but if you did X, Y, Z, it would make things a lot easier for us. It's having goodwill both ways. So that goes a long way, just from the deployment perspective, but also from a monitoring perspective. I need these sorts of metrics. Can you add these? Or, hey, even better, I've got a PR. I'd really love it if you took this PR, this pull request to your code, so you can start also exporting these metrics that would help us monitor your systems better. And you can see that, that pattern can also evolve in different ways where, protocol is new and they may want something like Blockdaemon to help kickstart their network. Say, we need a good, reliable node provider to give us kind of the basis for seeding the network. That's not to say it's going to look like that in 10 years, but at least now to get things running, we want to make things, we're in the test network stage. We're trying to attract developers, and it's really important that their experience is a good one. So they want to go to a professional like us to help them kickstart their network. And as part of that, working with those developers, you say, hey, if you want your network to be stable, we need to be able to monitor X, Y, Z. Because in our experience, that's what we need, not just for your protocol, but for our experience across a lot of different protocols. So that kind of cooperative work is super important. It can be very, very challenging, especially when we're trying to deal with so many different protocols. But, we kind of try to pick and choose where we can really optimize our efforts and our resources towards that.
You mentioned the standardization of data across protocols and how that's kind of an ideal outcome. You don't want to have everything being specific, unique to its own little bubble, for lack of a better word. But when you look at blockchain infrastructure today and the node industry, the blockchain industry, how do you see it evolving over the next 5-10 years as the industry matures, as infrastructure becomes better, as the monitoring systems in place become more evolved? How do you see the industry evolving from your own perspective?
Yeah, I think certainly one of the first things you're going to see, I really do think that I think the numbers of protocols, especially the very large networks, will start to converge to a smaller subset. There'll be maybe half a dozen to a dozen that are really dominant, and the rest kind of maybe some also-rans, maybe some networks that come and go. We know historically there's also been other reasons why protocols might fail. But in general, I think all those, especially the more mature networks, they all start to running the same problems. So they'll start to look the same because they're all trying to solve the same problems. And one of those things is monitoring and observability. The other one is, like you say, the data shape. Once everybody starts concluding that they want the data shape to look a certain way, because they have to, because now, it used to be have all these different protocols, but now they got to talk. They got to do bridging. You got to be able to do swaps. They got to have, maybe you need an EVM. Maybe you need to do different things with, ERC. You need all these kinds of things that are trying to converge towards kind of de facto standards. So all those things contribute to that, exactly that. And, for a lot of people, especially maximalists, they might be a little terrified. They're like, no, we want more diversity. We kind of want things to be, the technology to be flexible. Yeah, that's true. But you still want some sort of data uniformity, both in the form of what a transaction looks like and also, most importantly, what the monitoring stack looks like. And I think throughout, as these things mature, they kind of need to, because it's going to go more from the hobbyist perspective and more from the professional, industrial grade, we need to do this at scale, and you can't just play it by ear anymore. You got to really plan out what it's going to look like. And as things mature, it's like any other technology. I think blockchain is absolutely, if it's going to survive, it has to do that. So, I don't think there's much of I don't even think it's a matter of I'm not looking at some crystal ball and making a guess. The answer is absolutely they're going to have to look like that if they're going to survive.
Nye, thank you very much for your insight today. Fascinating conversation, and I appreciate the time.
Thank you, Connor. I had a great time as usual, though.